Alright, today we will be learning how to use the binomial theorem.
First off, what is the binomial theorem used for? Binomial theorem is used to expand binomials that are raised to high powers. For example, if you had the binomial x plus 5 raised to the 7th, this would be very hard to expand traditionally. However, using the binomial theorem makes this much easier. First off, we use Pascal's triangle to solve for the leading coefficients of the binomial expression we are expanding. To find Pascal's triangle, we'll start with 3 ones, as shown here. Next, you will proceed by adding all the numbers closest to each other. For example, these ones will go to 2, but since this one has nothing on the right, you bring down the ones, and same on the left. For the next row, you will add the 1 and 2, because they're by each other, and repeat the process across. For the next row, you'll do the same thing. And so on.
A general formula for using Pascal's triangle would be x plus y to say the fourth. So since this is a fourth power polynomial, we'll go down Pascal's triangle. This one's 0, 1, 2, 3, and 4. So we'll use this row of leading coefficients. Alright, so we'll start out by just putting the leading coefficients in. This is 1 plus 4 plus 6 plus 4 plus 1. Now, when we are solving for the inner part of the polynomial, we start with the first term, which would be x, and x would have a fourth power, and the y would have a power to the 0. So these two terms' powers have to add to the power on the outside here. As you can see, x to the fourth plus y to the 0, 4 plus 0 equals 4. And then as we go down, the x's would go down a power and the y's will go up a power. So x to the third, y to the first. This next one would be x squared, y squared. This would be x to the first, y cubed, and x to the 0, y to the fourth. From here we can cancel some unnecessary terms, such as y to the 0 and x to the 0, and we can also cancel out this 1 and this 1. Now I can just write the finished product, x to the fourth plus 4x to the third y plus 6x squared y squared plus 4x plus y cubed plus y to the fourth.
Sometimes you'll be given binomials that aren't in the general form as given on the previous slide. For example, we could take the binomial x plus 2 to the third. First off, we look and see that the power is 3. So we will go to the third row in Pascal's triangle. We'll see the coefficients are 1, 3, 3, and 1. So we'll proceed to expand it as we did before. We'll do 1 x cubed times 2 raised to the 0 plus 3 x squared times 2 raised to the 1 plus 3 3x to the 1 times 2 squared plus 1x to the 0 times 2 cubed. So once again, we will cancel out the terms that are not needed. We can get rid of the 1 at the beginning and at the end because they have no effect, and also cancel out the terms raised to the 0 power. After canceling, we will be left with x cubed plus 3x squared times 2 plus 3x times 2 squared plus 2 cubed. After distributing the exponents, you'll be left with x cubed plus 6x squared plus 12x plus 8.